bienvenue à tous pour cette session plénière. Welcome to everybody to this plenary session 3. It's a great pleasure for me to welcome today Elisabeth Bik. We will discuss the dark side of science through some example coming from the biomedical field. I'm not going to reread Elisabeth's biography, which is very complete on the site, but just give you a free reminders and a summary of my discussion with her in preparation for this presentation. After a PhD in microbiology at the Utrecht University, Netherlands, she emigrates to the United States 20 years ago to work in a laboratory at Stanford University, a lab pioneer in microbiomes of humans and marine mammals researches. I encourage you to ask a question about our research on dolphins used as sniffer dogs. Fascinating. After 15 years in the lab and an experience of being plagiarized, she started working on the subject of plagiarism and scientific integrity in general, and discovered that she had a real talent for it. What I retained from our discussion, Elisabeth, and I quote, "Plagiarism is bad for the scientists, but not bad for the science." Thanks to explain that to us. It's your turn. Thank you very much for being with us.
Thank you so much, Laura. That was wonderful. And let me share my screen. It's the awkward going in between. There's my screen. And that should look good. Yeah, so after my career in sampling dolphins, I guess, I switched to science integrity. And so I am currently a consultant. I'm not employed. And I screen the scientific literature for all kinds of problems. And I'll talk about that in a bit. But before I go into my talk, I will disclose some of the ways I make a living, because I have a lot of trolls on Twitter who follow me and who are always asking me, how do you make your living? Are you paid by the pharmaceutical industry? And so I'm not paid by the pharmaceutical industry, but I will offer consulting for science integrity and occasionally microbiome analytics, which is my previous job. And so I work mainly for universities and scientific publishers. I will occasionally get speakers honoraria to give seminars. My name is on 4 patents. I worked at uBiome, which is a company that got raided by the FBI, and the founders are currently being charged with fraud. I had nothing to do with that, but I have 4 patents, and I don't think they're worth a lot of money, but there they are. And I do have a Patreon account, which is where people can donate $1 or $10 or whatever you can miss to support my work. So those are my sources of income. I also would like to thank a lot of people who are doing similar work as I do, who are critical of scientific papers after they have been published, and who provide the platforms to raise these concerns. So I want to specifically mention PubPeer, which is a website where I will discuss scientific papers, and I'll talk about that later in my talk. But most of these people are doing similar work as I do, but maybe a little bit less visible. They might work under a pseudonym, or they might do the work combined with their normal work, so they don't really have a lot of time. But these are all people who are very passionate about science papers and who want to correct them. And so why do we care about science papers? Why do we look at science papers and find errors? We do that because we care about science, because science builds upon science. So every science paper is used by other science papers as a building block or as a starting point for new research. So every scientist will look at the literature and we'll see a lot of papers that have been published and will base their work upon that. So I see science as a brick wall onto which every generation of scientists layers another layer of bricks. So if one of those bricks, one of those publications contains either an error or scientific fraud, can be both, that means that other people will waste a lot of time trying to replicate those results. If that brick contains an error or fraud, the other bricks on top of that are not on stable ground, and the wall might tumble down, or at least part of a wall. Now, most scientists are honest and hardworking. I don't want to say that all scientists are fraudulent. That's really not the case. I'm really focusing on a very small fraction of scientists that might be fraudulent. But science as a field also is not immune to fraud. I think a lot of scientists are sometimes thinking that everybody is super honest and that you can believe all the results. And that's also not the case. So there is fraud in science, like there is fraud in many other places. Now, fraud is a big word, and not all the problems that I'm finding in a paper are fraud. It's a slippery slope from making an error, as we all do, to maybe being a little bit biased, or picking a particular result that gives the best output, maybe leaving out outliers, but it is a slippery slope on towards real fraud. And in the United States, we have the Office of Research Integrity, ORI, and that oversees misconduct, which is funded for research that has been funded by the National Institutes of Health. And they define science misconduct as one of three things: plagiarism, falsification, and fabrication. So plagiarism is where a person steals somebody else's words or ideas and passes that off as their own. And I don't think that's the worst offense of these three, because it's still science. It's not bad for science. It doesn't bring in any false ideas, but it's of course very bad for the scientists who originally did that. We should contribute each other. We should credit each other for the work that we've done. And then falsification and fabrication, I think, in my opinion, are even worse. So falsification is where a person does an experiment, but leaves out a particular result, an outlier that doesn't fit in the hypothesis or doesn't fit in the beautiful curve, or when they change the values that they have measured. For example, they increase a couple of values, a couple of data points to pass a threshold or to just fall under a threshold. So basically, yeah, the results are there, but they're not, the researcher didn't like them and will change them a little bit. So fabrication then is where a person completely makes up results. So there was no experiment done. A person just types in a couple of numbers in a spreadsheet and passes that off as science results. So those are the three definitions, the three things that fall under the definition of science misconduct in the United States, at least. But there are other things that you can think of, and I'll mention a couple later in my talk, that you can also consider to be science misconduct. So there can be all kinds of problems in scientific papers. I listed a couple. So not all of these are misconduct, but they're problems in scientific papers that could lead to other people trying to replicate those results, but not succeeding in that. So I've listed a couple. I mean, this list is not complete, but just a couple that I have come across. So you can have study setup problems. For example, you can have a study in which the control and the treatment group are not the same. And of course, they should be the same in every respect, like the same age, the same gender distribution, the same health status, except for whether or not they're being treated. So there can be problems with that. There can be misinterpretation of results, where a person just failed to think of another possibility to explain the results they've measured. There can be all kinds of errors in statistics, calculations. I've also seen papers with really, really tiny error bars where you just know that's not how biology works. Like, you would not expect every measurement to be exactly the same. There's an undisclosed conflict of interest. For example, a person might have a patent or company stock and not mention that, and say that a particular product from their company is wonderful, but fails to mention that they have a financial advantage of publishing that. And it's not necessarily wrong to have a conflict of interest, but it's wrong to not disclose it, to not tell about that. And then there can be all kinds of problems with animal ethics or human subject ethics. For example, there can be a lack of approval, or the study has started before the approval has been obtained. Or there can be photos of very large tumors in animals, which are not allowed. Papers can have excessive self-citations, where half of the papers that have been cited are from the authors themselves. That's also not a very good thing. Plagiarism, I've mentioned, concerns about the peer review process. And the part that I'm focusing on is duplicated or altered photographic images. So that is my specialty. I find those, and I'll tell more about that in the following slides. So there's a range of problems that you can come across even by looking at a paper that has already been peer reviewed and published, because peer reviewers might miss certain things, might be biased, might be short on time, and it's usually only 2 or 3 people who peer review a paper. Well, once a paper has been published, there's many more eyes on it, and problems might arise or might be found even after the paper has been published. And in my opinion, after a paper has been published, it's not a solid block of truth. We can still criticize it and we can still discuss it. This is how science should be. So there have been many cases of science misconduct that have been discussed widely in the news. I've listed here 4 cases just to show that science misconduct can happen anywhere in the world and in any science field. I don't think that any particular science field is more or less prone for fraud. That probably happens everywhere. So these 4 cases are Andrew Wakefield, Jan-Hendrik Schön, Haruko Obokata, and Diederik Stapel. So Andrew Wakefield is a doctor who claimed that vaccines caused autism, but his Lancet paper turned out to contain a lot of falsified data. He described 12 patients, but he changed some of the dates to make it look like these children had autism-like symptoms after they had been vaccinated, while in reality, some of them had already these symptoms before the vaccination. But still, even after his paper got retracted after a long fight, a lot of people believe that certain vaccines cause autism, and this is still a very widely believed concept, even though this paper was science misconduct. And this paper is probably the one that got the most influence and is still being believed, and so has done a lot of damage, in my opinion, because a lot of children have not been vaccinated based on this paper, and might have, even some people might have died of measles, for example, preventable diseases. In physics, there was the case of Jan-Hendrik Schön. He worked in the USA, he worked on semiconductors. He fabricated his result, he made up results, and is up to 28 retractions. And then Haruko Obokata in Japan worked on stem cells or stem-like cells, and has 2 retractions. And in the Netherlands, we have the case of Diederik Stapel, who worked in psychology and who also fabricated his result. He is up to 58 retractions, and that was, I am from the Netherlands, so this was a big shockwave in research in the Netherlands, that a person could just make up 58 studies and probably even more. So science misconduct can happen everywhere. I've not been involved in these cases, but what I specialize in is looking at images such as the ones you're seeing right now. So most scientific papers do not have photos. They might have line graphs or just text or tables or things like that. But in the biomedical literature, in particular parts of particular fields, you might see photos like these of gels, of blots, of tissues, of cells. And if you look at these photos, they might all look similar to each other. They might all look, black with green cells, or they might all look like black stripes on a background. But if you look at them carefully, you can see that each of these bands and each of these panels is different from the other. They're all unique, and you can tell them apart. So all these photos are fine, nothing wrong with them. But I specialize in finding duplications. And so here are a couple of photos that I found throughout my searches. that of images that have big problems. And I sort of have a couple of different examples to show you the different types of problems I might see in these photographic images. So I'm looking for duplications. So basically the same photo being used twice to represent two different experiments. That's an inappropriate. If it's appropriate, I would not flag it. But in all these cases, there are different experiments being shown that, but the same photo. And if we start at the top left, you'll see a bunch of panels that all look unique, but you'll see that two of them, which I've marked here with the red boxes, those photos are identical. And here are two other photos, another pair marked by me in blue, that are also identical. So there's a lot of photos here, a lot of panels. Each of these panels represents a different strain or a different experiment. I removed the labels, but they should all look different, but they're not. And so this is what I call a simple duplication. It's the same exact photo being used twice, but representing different experiments. Now, this could just be an honest error. The author might just have mislabeled their photos, or they might be a little bit sloppy and they just by accident inserted the same photo twice. That can happen. So this is not necessarily misconduct. This could just be an error. If we look at these two photos here, there's also a duplicated photo, but it's shifted a little bit. There could either be a rotation or a mirroring, things like that. If we look at this example where we see 4 different photos, each of cells being treated with a different amount of radiation, you can see that the 0 and 2 gray panels overlap. If you focus, for example, on this group of cells here, you might see that here as well. So it's the same photo, but it's zoomed out and it's shifted under the microscope a little bit. These are cells. And the same here, the 2 gray and the 8 gray photos also appear to show the same cells. So again, there is a shift under the microscope of the specimen, and also a distortion of the photo a little bit. It's not, here it's more a rectangle and here it's more a square. And this is what I call a repositioned duplication. So it's not just a simple photo, there is a shift or a rotation or mirroring. Same is going on here in this example at the bottom right, where you see 2 Western blots, that 2 protein blots that overlap with each other, but they're shifted 2 lanes, but they're representing 2 different cellular locations and 2 different proteins. And so that is not good. Again, there's a shift of the photo. So these are repositioned duplications. And then on the bottom left, I have an example of what I call an alteration in the duplication. So it's a duplication basically within the same photo. You see 4 different panels, and panel A will have, you can see that lane 1 and lane 3 appear to look identical. And in panel D, we see that lanes 2, 3, and 4 appear to look identical. So here we're looking at a photo in which within the same photo, you'll see the same element twice or even 3 times. It could also be a photo of cells where you see the same cells showing up multiple times. That's very unexpected. And this is basically photoshopping, I think, but very unlikely to have happened by error. So this is very likely done with the intention to mislead the reader. So this appears to be done intentionally, while the simple duplication appeared to be done by error. And so this classification of photos helps me a little bit to know which papers might have been containing problems by error or by misconduct. It is very hard for me to tell it for an individual paper because I don't know, maybe you don't really know what happened. So I will just usually flag the duplications and leave it up to the editors-in-chief of the journals to figure out what happened. But I did do this as a strange hobby, and I turned this into a science project by scanning 20,000 papers. And a lot of people believe that that is not possible, but I'm only looking at the images. I'm not reading the papers. So it's much faster than you might think. So I scanned 20,000 papers by eye, and I found a lot of duplications. I made sure to include different types of journals, 40 different journals, but they're all in the biomedical literature. They're all on cancer research, microbiology, which is my own field, etc. I made sure to include 14 different publishers, and I found in this set of 20,000, 800 papers to contain these duplicated images. So that's 4% of these papers that I scanned. I have to also point out, I only scanned papers that had at least one photo. If they only had tables or line graphs, I didn't count them. So this is really focusing on papers with photographic images. And so 4% of these contained inappropriately duplicated images. And I showed you the 3 different types. So since they were, we sort of made an estimate that the simple types were usually done by error, and the altered ones were done intentionally. So we sort of made the best guess we could that about half of the papers that I found, so 2% of all papers that I scanned, contained photos with intentionally duplicated images. There was so much rotation or alteration going on that was hard to believe to be done by honest error. Now, does that mean that, can you extrapolate that to all scientific papers? Is 2% of all papers misconduct? Does it contain fraud or misconduct, at least in images? That's hard to say. It might be even higher because I could only look at photos, and it's relatively easy to spot these duplications in photos. But if you think of tables and line graphs, how easy would it be for a person to change the results in the lab and then publish it without me or anybody else noticing that? That would be much easier. And so I think that the real percentage of fraud is much higher than 2%. It might be in the 5 to 10% range. And that's a scary number because as a researcher, you probably will come across a couple of these papers. If it's in the 5% range, that's a very high number. And it's much harder to detect. So I usually play a game on Twitter called Image Forensics, where I'll post an image and people can spot and see if they have the talent to spot these overlapping images. And it works really well in a conference room, but it doesn't really work well on Zoom. So I'll just show this image and then I'll show you the duplication. So you might come across an image like this in a scientific paper and look, oh yeah, there's lots of different treatments and lots of different protein stainings. And so all these photos should look unique. There should not be an overlap. They're all different. But yet, if you look carefully, you might see that a lot of them show overlapping parts. And so this is how I've labeled this paper. And this paper I reported in February 2015 to the journal, and it got retracted a couple of months later, which I think is a good outcome. I think there's so many errors in this photo, or it was done intentionally, I don't know, but it's so many that I would not trust any data from this lab. They're either super sloppy or they're fraudulent. But it's I would not base my research based on these results. So here's another example. These are 4 different treated leukemia cells that were treated with 4 different treatments. Each of these photos should look unique. It's not a time series or so. And yet, if you look carefully and focus, for example, on these 3 cells, you might see them here in treatment C as well. And if you look at this group of cells with the red and the 2 yellow cells, you might see it here as well in mirror image. And so this is how I've labeled this photo. There's lots of repeating elements, and this appears to be done intentionally. This paper I reported to the journal, but is still out there, is not being retracted. And that's frustrating because I think there's a big problem here, and the editor did not respond to my comments. Here's another example. These are protein gels and blots. And you might, if you look carefully at this image, you might notice this little scratch here. And you can see that here as well. And if you then sort of squint your eyes a little bit, you might see that these 2 lanes look exactly the same as these 2 lanes. And you can see them here one more time. So there's actually 3 occurrences of the same lanes. And I've marked it as here with these red boxes. And this is a remarkable paper because this got published in Science. Science is one of the top journals. This paper got cited 830 times. 830 other researchers based their research on this paper. And I reported it to the journal, and I felt very scary because, you know, I was a researcher, and you basically send a letter to Science, which is the top journal that we all hope to publish in one day, and then they didn't respond. So this paper is still uncorrected, unretracted. It has a huge problem, cited a lot of times, very popular paper, and the journal did not act. They did not retract, they did not correct, they did nothing. It's still out there. And that's frustrating because I did it the professional way, and why didn't the journal not respond? So how do you report these things? So I report them normally to the editor-in-chief of the journal, but you can also contact the research integrity officer of your university. So here's an example. For example, I gave this talk at the University of Rochester, and you can write to the integrity officer of that university, say, oh, I found a paper with a problem. But what is most important is to remain objective. So I will not say, or try not to say, because sometimes that is hard. I will say figure 2A looks remarkably similar to figure 4B, or these two lanes look very similar to each other. But I will not say, make any accusations. I will not say this is intentionally done, this is fraud, this paper should be retracted. I will not say that. I will only say these things look remarkably similar. And there can also be all kinds of other problems like conflicts of interest and ethical issues that I mentioned previously. But just try to remain objective and write to the editor-in-chief of the journal. And so hopefully that editor or that research integrity officer will start an investigation. And you can imagine that that will take some time because they need to contact the authors. The authors need to reply back. Maybe they don't reply. Maybe their email address doesn't work anymore because this paper is 5 years old and they have moved to a different university. Or maybe the authors will all point fingers at each other saying, like, it's usually the senior person who says, no, it was the junior person. I have nothing to do with this paper. My name is on it, but I'm not responsible. It's somebody else. As we call in the United States, that is throwing somebody under the bus, basically blaming somebody else for a problem. So these things can take a while. I would not expect the papers to be retracted or corrected in a week or a month, but I've waited 5 years. So most of the papers that I found in my initial scan of 20,000 papers, so those 800 papers I've reported in 2015 to the editor. So we're 5-6 years later, and I know what happened to these papers. So only 28% have been corrected. That could be a good outcome. 10% have been retracted. That's a good outcome in case of really big problems. But 60% of papers have not been acted upon. So the majority of the papers have not been corrected or retracted. The editor just did not want to take any action. So that is frustrating because I try to, discreetly send an email and get this fixed. But the editors have seem to be either very busy or overwhelmed or do not want to handle these cases. So I'm taking things a little bit more to the public space because I feel it's not in the interest of the reader to not correct these things. The reader has no idea that there might be a big problem with this paper. And why are these things not brought in the open? So I post most of my findings nowadays on a website called pubpeer.com. And PubPeer is a website where you can leave comments on one particular paper. So every paper, it goes by the unique identifier of that paper. So every paper has most papers have a DOI, a unique identifier. And so you can leave your comments on a paper on the website. If you also install a plugin that will work with one of your browsers or even with the citation manager Zotero, that means that during your literature searches, you can see which papers have had a PubPeer comment. And it works really well. So you'll do your PubMed search, you'll see a lot of different papers and you'll see, oh, this paper has a PubPeer comment. Let's see what other people had to say about it. Now, most of the PubPeer comments are these types of image problems that I've showed you previously, but there can be all kinds of other things like ethical issues or conflicts of interest. And And that works really well. So I've posted around 4,000 papers by now on Papier. And occasionally I will talk about these things on Twitter. So my handle is Microbiome Digest. And so the science paper I showed you in the previous slide, I have discussed on Twitter, because I think that's not good. I will usually not say which particular paper it is. I don't find that that I should really blame people, but I'll show the problem. So I'll usually remove some of the identifiers and not say which paper, just show the problem. And in this case, I did say which journal it was. And here's another example where I found problems in a paper published in Nature by Harvard scientists. So that was pretty high, and they had big problems. And this paper got retracted. So this paper got a little bit better handled, in my opinion. So I've talked about all kinds of problems. There's many different problems that you could see in scientific literature. So it's there's many other types of problems. There can be problems with peer review, where people peer review their own papers. There can be fake affiliations, where people claim to work at a particular institution which doesn't exist. And so these are all potential misconduct, because it means that that there's not an objective way of analyzing their results or obtaining ethical approval for their research. So there's many of these people who make up their own institution. I will point out there's this person who has made up the California South University, which does not exist, but has set up a complete website that looks very real, but it's all stolen text and images from other websites of university. And it's actually amazing how much work this person has put in setting up a completely fake affiliation. There are predatory publishers, which are journals and publishers that sort of make misuse of the open access model. They offer very fast peer review, and you might get, as a researcher, you might get these emails saying, "Dear esteemed researcher, we would love you to publish in our journal." And you might think that's a real journal. But by the time you've published your paper, you will then maybe notice that this journal is not really accessible if you do your normal literature searches. Nobody will find your paper. It will live in a dark corner of the internet and nobody will see it. And then it's hard to get it retracted and published in a real journal. So these journals have all kinds of problems, but it's also very hard sometimes to distinguish a real journal from a predatory, because there's a lot of gray zone in between. Some people actually make misuse or deliberately publish in these predatory journals because they cannot get their paper published in a real journal, because the peer review would say, "Oh, this is not a good paper." But these predatory publishers will publish anything as long as you pay them. And so some lone authors with wild ideas, like the California South University guy that I mentioned in the previous slide, they will deliberately publish in these journals and publish one paper after another. But they're really very low quality journals usually. And then there's a particular problem called paper mills, which I've also worked on in combination with some of the group people I've mentioned in one of my first slides. Those a lot of anonymous accounts on Twitter who are doing similar work as I do. So I want to credit them. So there's a specific incentive in China. If you are a medical doctor and you're done with your medical school and you want to work at a hospital, there's a requirement that you have to publish a scientific paper. And that sounds sort of easy, but scientific research is actually hard to do. And you cannot really do it sort of if you already have a full-time job, and especially if you're a doctor and you have like a 60 or 90-hour work week, you cannot really do research on the side. But yet these people have to publish a paper, and they're in an impossible situation. So there are companies that offer them authorship on a paper, and so they have to pay a pretty large sum of money, and then they'll have to but then they can get their name on a paper. So these papers are not real. We believe they're completely fake, but they're written with a template. So there's people, ghostwriters, who write these papers, and they change the text every time a little bit. They change gastric cancer to prostate cancer, and now you have a new paper. Or they change some of the graphs. So they probably work with writers and designers who sort of make these new fake papers, all based on a template. And they have very similar title structures. And so as an example, here are two different papers from, so these are two different papers, left and right, published by different groups of authors. And they look different, like these doesn't look like plagiarism, doesn't look like duplication or so. But if you really zoom in carefully and you look at this particular photo here and this particular photo here and compare them next to each other, so here you have from the left paper and the right paper, they still look different if at first glance, but if you look even more carefully, you might see here, this is a scratch assay, and you might see this letter, it almost looks like a letter J. And you can see that here as well, but it's upside down. So this is the same photo. It's rotated, but it's being used to represent two different experiments. So this paper mill, as we call it, this group of papers, had 125 papers, and they're currently being retracted because the photos are real, but they're probably just, they were an original experiment, but they're being reused to represent all kinds of different experiments in 125 papers. Here's another example where you see a lot of different plots and see duplicated areas. So these plots all look very similar to each other. They're a little bit different, they have different labels. They're from 4 different papers, but they appear to be all the same plot. And then here's another example where you have unexpected findings. This is a paper on prostate cancer, but it lists equally, like even more females than males, which is very unexpected. You would not expect half of your prostate cancers patients to be female. So it appears that this is a template table in which, the studio forgot to adapt one little thing. So they make errors, and this is how you can recognize these journals and these papers. But it's very hard sometimes, because if this is gastric cancer, you would totally believe this table. And then, of course, we've had a pandemic, and the COVID-19 pandemic brought along an enormous amount of papers. So there's just an explosion of papers. There's like 16,000 preprints on medRxiv. And many of these papers have been published in a, to be honest, we've been in a panic situation as scientists in the past year. There's a new pandemic, people were dying. What do we do? Which vaccines might work? Which drugs might work? Which is the best treatment? And there have been just an explosion of papers on this topic. Most of these are opinion or editorial pieces, and they're hastily written, especially in the first half year, the first 6 months of 2020. Lots of retractions have already happened because some of these papers are just fraudulent or contain huge errors. And it seems that a lot of scientists wanted to have at least one COVID-19 papers, and so a lot of bad things happened. There was just not a good quality control. Normally, good science happens very slowly, and I think everybody was just trying to move too fast, which is understandable, but it also erodes, damages the trust of the public in scientific papers. So a very specific example of a paper that I've criticized is a paper that had a huge effect on the way that COVID-19 patients have been treated. So this paper was published by a professor in a Marseille lab, who we probably are all familiar with. And this paper got actually tweeted in the United States by our president, Donald Trump. I think this is the first and the last time that he tweeted about a science paper, which was remarkable. And he says, "Oh, this paper is going to be a game changer. This is a wonderful hydroxychloroquine is going to be the answer to everything." And so I took a look at this paper, and it's a very small paper. It had a small group of patients, and so some were treated with were not treated, and some were treated with hydroxychloroquine and azithromycin, which is an antibiotic, and those 6 patients did really well. So based on 6 patients, this paper got published, and a lot of countries suddenly switched to hydroxychloroquine. And so can you make big changes in science just based on a very small group of patients? Well, maybe if it was a good paper, yes, but I think this particular paper had a lot of problems. The study appears to have been started before the ethical approval was obtained. If you look at all the dates that are listed in the paper, there were differences between the control group and the treatment groups. For example, they were in different hospitals, they had different age distributions, different types of PCR tests, and the patients, most importantly, were not randomized. It appears they were handpicked and put in one group or another group, which is not how good science works, because maybe you could make all kinds of decisions, and maybe your control group is then different than your treatment group. And then 6 patients were actually left out of the study. So 6 patients who were started on hydroxychloroquine, 1 of them died, 3 of them got really bad and went to the ICU. But they were left out of the study. And you cannot just say, oh, let's just leave out the undesired patients or the undesired results, and now my results look much better. Of course, that's not really how science should work. So this is in my opinion, leaving out results you don't want, and that's not good. The peer review was done in 24 hours, and the editor-in-chief of the journal was also an author on the paper. So that looks like the peer review was not really done independently and objectively. So I wrote a papier criticism, and I also wrote a blog post about this. Of course, the senior author was not very happy with it. I also found many other papers of that group to have problems with image duplication, with ethical approval. And so I was very critical of this person and found several other problems in this lab. But then there was also the other side of the discussion. So this first paper was saying that hydroxychloroquine worked really well. And I wasn't anti-hydroxychloroquine. I was just thinking that this was not a very good paper. But then there was another paper that came out in The Lancet that claimed that hydroxychloroquine did not work at all, and it was actually very damaging for patients. So that paper was not based on just 6 patients or a very small group. It appears to have looked at 96,000 patients. So that was a huge paper. And the data was collected and distributed by a company called Surgisphere. Now, at some point, it turned out that this data set was not, was maybe only partial real or completely fraudulent. That I'm not quite sure what happened in the background, but suddenly this paper got retracted because people started to notice that some of the numbers of all these different hospitals didn't make up, and that nobody from these hospitals had actually given this data to this person who claimed to have this data set. So if this data was made up or not, I'm not quite sure about, but the paper got retracted. So there was definitely a big problem with it. But the senior author, the person who claimed to have gotten the data, if you look at his PhD work, so which I did, I found that his PhD work had this beautiful image. And these are inner ear structures of rodents, although they look like Melba toast. But yeah, there's lots of duplicated parts in these images. So it looks like this person is not a stranger to maybe making up data. Unfortunately, this paper, I reported it, but the institution, the university and the journal do not seem to find that this is a big problem. And so this paper is not being retracted. It's still out there, but it has a big problem, in my opinion. So there was, in my opinion, there were bad things happening on both sides of the equation, whether or not hydroxychloroquine works. Both papers appear to have big problems. And then, of course, because of the concerns are raised on these papers, the senior author from Marseille is now starting a legal threat against me, and several others are also starting legal threats against me. So I feel I'm raising concerns about papers, but I'm now facing legal action. And so it seems that the scientific discussion is no longer happening in the scientific arena, but is moving to the legal arena. And so I'm being threatened with several lawsuits by raising what I feel are legitimate concerns about papers. And so this is, I guess, the world we live in, that as scientists, we cannot really discuss these things anymore. We're we're threatened to be silenced. So as a final slide, this is my final slide, I do want to sort of discuss a lot of things that I've discussed before. And these are discussion points. I don't have always the answers to these questions. For example, what is the percentage of misconduct in total? This is a question we can probably never answer, because nobody, if you are a fraudster, you're probably not going to admit that you have done fraud. So, but I think it would be between 5 and 10% of papers that contains misconduct. And especially with all these paper mill papers that are being produced right now, which are hard to recognize as an individual paper. I think that in certain fields appear to be completely infiltrated with fake papers. So the percentage of misconduct might be much higher than 10%. Why do people do it? I have different scenarios in my head. Like I can see the person who was very successful in the past and has published in high impact journals, has tasted success, has done interviews. That's all lovely. But once you've done that, it's really hard then if your research maybe then moves to a different topic and is not working as well. The experiments don't work, the results are not there. And suddenly you're not being interviewed, you're not being invited anymore to give a talk. And so these people are maybe addicted to the success they had, and they want to continue that, and they start to make up data, or they start to at least cut corners and not be as accurate anymore as they used to be. But there could also be a person, a junior person who works in a lab where the professor is a bully, where the professor is threatening to fire the employee unless they produce certain results. Like, I want this blot by Friday and I want it to look like this. Well, what do you do in this situation, especially when you're on a visa, where you're dependent on your professor for your letter of recommendation? Then I think you're in a situation where you are tempted to do misconduct. There might be other scenarios, but I'm sympathetic for the sad stories behind the scenes. And I feel that's also the reason I try to not make it about the researchers as much. I try to make it about the research, the papers and the results. Whose role is it to detect misconduct? I'm an unpaid volunteer, I guess. And should journals not be a little bit more scrutinizing papers and a little bit more aware that certain papers might contain fraudulent data? Do we offer any legal protection for whistleblowers? I'm not sure if I'm a whistleblower because I'm not an internal person who has particular information. I just look at published papers, so anybody could see this. Yeah, I try to raise real concerns, but I'm not being protected at all. I don't work for a university, so there's nobody who's going to pay my legal fees except for myself. And so I'm taking a huge risk, personal risk, and huge financial risk for raising these concerns. But I feel as scientists, we should all be supportive. And luckily, I am currently being supported by a lot of scientists there's several petitions supporting my work. And I'm very grateful for that. But in the end, I am in a very risky position. There's all kinds of conflicts of interest. I've discussed that some people some editors are not really taking any action. And why is that? But in the end, there's also a tremendous cost of misconduct, not just for scientists who try to replicate these results, but for science as a whole, because it's so damaging for science to talk about these cases. And it might be easy for the general audience to think that all science is fraudulent, which it's really not. Like, most scientists are hardworking and honest, but it's easy to walk away from my talk and think that all science is flawed. So that's definitely not the case. And I hope that you're happy that there are scientists like me who try to correct the literature and make it better. So if you are on Twitter, I would recommend you follow me, and will play occasionally the game called Image Forensics, where I'll have little puzzles and you can see if you can spot it. And I will hand out an emoji medal to the first person who gets it. And with that, I will stop sharing and take any questions. Thank you so much.
Thank you so much, Elisabeth. So fantastic. I was dreaming about that types of topic. You did it. Thank you so much.
You're very welcome.
thank you for this really, really interesting session, speak. And there is a lot of questions on the chat. Please, we will, if the first one, you can take the lead, please, and ask directly your question to Elisabeth, because sometimes the chat is not really clear. So there is we can begin with Olivier Sandre. Olivier?
Hello, everybody.
Hello.
Hello, Elisabeth. Yes, I thank you very much. So my question in the chat was, what is your experience about the response brought by the French or French-speaking universities? There have been cases, we all know this Olivier Voinet case that occurred. That was really annoying, and that shed light on this topic of fraud. Do you think there is a particularity in our university compared to the other one?
Well, first of all, there's fraud everywhere, and there's bad responses all over the world. I have been, I was not involved in the Voinet case myself, but it seems that sometimes people are just protected by their university, and it's. I'm not sure if the situation in France is very different. People have told me it's very hard to fire a person once they have a university position. And so that might be a problem where if there's real fraud or misconduct or anything, like how easy is it for a university to fire that person and to let them go? So if that's a problem in France, then that's a real problem. Like I feel there should be certain cases where people just cannot longer be protected. But it happens everywhere. There's been many situations internationally at the US, in other European countries, where I've been very frustrated with the response of the university. So it's not particular, I think, a French problem, but I feel in the particular case I'm now involved in with the Marseille lab, like I've written also to the university itself, because I'm being harassed by people from the IHU Méditerranée. I'm being personally harassed, and I've written to the university, can you at least, tell this guy to not harass me? And the university did not respond. Like I've wrote to 12 different persons, none of them responded. And I feel that's a really bad situation where like an international researcher is being harassed by a particular university. At least what the university should do is write me back and not ignore it, because I'm not going to go away. I'm not going to be intimidated by legal cases. So it appears that there's a lot of powerful people and there's a lot of protection, and these are old structures. And I hope with social media and international attention that we can break through these sort of old structures and make it better, because it is really tough to see how little support until now there was from French universities for this particular case. And it's only now that I feel with the international petition that people are starting to support me more publicly, but there seems a lot of intimidation and harassment going on at particular universities. And not only in France, that's
just to mention in the Raoult case, the case of Professor Costagliola, who is a medical research institute researcher, and she was also suited by the Raoult people, and her organization protected her, gave her this legal protection. So in your case, where also Boris Barbour, who is a researcher from the CNRS, I think the community of researchers, myself, I'm CNRS researcher, we are asking our organization to protect him, like, and you, of course, again, in this case.
Mm-hmm. Yeah, that's wonderful. It's been going on for too long.
Yeah, and I've put the letter. The letter was written by a postdoc, a French postdoc at Monash University, Loni
Yes.
Besançon, you know him?
Yes.
And any researcher, French or not, can sign it. I gave you the link to everyone.
Yeah, thank you for putting the link in the chat. Thank you very much.
Thank you.
Blondine?
Yeah,
How to explain the very long time delay for journals or publications to the comments? Is it due to the protocol defined by publisher?
There could also be all kinds of problems. I think in several of the cases where I have found, let's say, 40 different problems in a particular journal, I probably overwhelmed the editors because maybe they only had one case a year. And then suddenly there's Elisabeth Bik writing them, oh, I found 40 different papers. And they're like, oh, this problem is so big. And it's very human then to not respond to if you get faced with a overwhelming problem. But in other cases, yeah, I think in some cases the journal just did not respond at all. In other cases, they did respond by contacting the authors, but the authors didn't respond. And we all know, like, my email address on some of my papers doesn't work anymore because I don't work at that institution anymore. And so when people move on, especially if they in the ages when we didn't have an ORCID ID, it's hard to find some people. Some people have very common names. Some people have very unique names and are easy to find, but a lot of people have much harder to find names that could be written in different ways. And so it's just harder to find these people. So I think it's a combination of editors who are not really sure what to do, publishers who are not responding, authors who are not responding, and there are guidelines. So there's the Committee on Publication Ethics, COPE. They have very clear guidelines, which could be even more clear because there's certain things missing, which if a journal belongs to COPE, they should follow those guidelines. But the guidelines are a bit vague. For example, it says contact the author. The author will provide the original materials. But usually the author might not reply, and the original materials are gone. And so then I think people cannot go down the flow chart anymore. They stop, and they sort of so the flow charts do not really handle these types of cases, which are the most common ones. And so flow charts should be better. And yeah, it's just a combination of all kinds of factors. And academia is just such a slow moving thing. It's just not going to change very fast.
So I have to select because we are not so many them. Yes. Do you have from Theodore Leiber? Do you have an idea of a view of the extent of published bad quality fraudulent papers per scientific discipline?
That's hard to know because so I focus on images, and so I will by definition focus on papers that have photographic images. So that is all mainly molecular biology, nanobiology, or technology. But I've also come across of particular line graphs, which are very common in chemistry and physics, that can contain duplicated parts. But it's a little bit outside of my field, and it's harder to recognize. So because I focus on photos, I find these papers in papers that have photos. But it's probably happening in any field, but it's much
Yeah,
harder to detect.
thank you. Rob, a question about the sliding scale. Rob?
Yes. Oh, okay, I'm unable to go on video, it seems, for some reason. Okay, starting the video. Yes, I was just wondering because I'm working a bit more on the literature reviews, Elisabeth. So what you find is on the lower end of the spectrum, already that citing of studies is sometimes inaccurate. On the other end of the spectrum is the complete faking of a paper. And in the chat, maybe you have not seen it, I gave an example, by extent one of my own papers on outsourcing that was cited by a doctoral study in the UK, as having information, the core of the study about marketing variables, and the word marketing only appears in the names of journals in the list of references. But this person, because this is how I got hold of it, obviously has his PhD, I assume it is a he, but I don't know, accepted. And that means that that person already goes into the academic world without little penalization for doing something wrong. I mean, I just want to use the words black and white a bit over here. And then I think it's a sliding scale as well. You make a little mistake, you tend to make a bigger mistake. And it reminded me of the, as I thought I was a bit more into literature reviews. I have a big A3 where it shows, with plagiarism, and it is relatively small written like typeface 8, and there's only one box in the bottom on the right that is green. The rest is all orange and yellow and red because of the many mistakes you can make. So I was just wondering in this sense, if we don't teach it right from the beginning, how are we going to get it right at the end?
Yeah, and I agree. It's very frustrating to see that these people sort of throughout their career appear to remain fraudulent, and it could have been caught at a much earlier stage, like you said. And yeah, there's just very little punishment for these cases that everybody sort of knows that there's misconduct going on, but everybody seems to look the other way. And I don't have a good answer other than to share your frustration with the lack of punishment, which is a big word, but like there seems to be very little repercussions for these people, and we should do better, because it also tells other young researchers that maybe it's okay to do fraud, and that's not the message we want to send out. We do want to keep science, good and pure. That's maybe
So does open science then help in terms of the open peer reviews, do you think? Which makes it easier to at least attach comments
maybe, yeah. But I think we need to end, right?
Thank you. Sorry, but
I know,
and I have really the last but not the least question, very, very interesting, from Guillaume. I can see a question about retracting fraudulent articles. In the case of articles basing their research on a fraudulent paper, should these articles be retracted or corrected also? Is there a standard procedure? As a fraudulent paper could lead to an exponential number of wrong papers, even without fraudulent intention from the other authors.
Yeah,
very interesting. Thank you.
Good question. I don't think those papers should be retracted, but I think a lot of people might not know that a paper is retracted and might cite it. We all have our favorite papers, and it's hard to know if a paper in the meantime has been retracted. So there are committees, I'm part of one of them, to do better checks if a paper gets at a submission stage, to check all the papers to see if there has been retractions and corrections, and to contact the authors and let them know, like, did you know that you cite your paper, a retracted paper? And I don't think those papers should be retracted, but in most cases, we only use a tiny sliver from one paper. And I could see particular cases where the retracted paper will have a huge impact on a paper, but in a list of 50 or so citations, it's maybe only one paper that is really the important one. So I think we should let the authors know, but not retract the papers, because if they were able to replicate their results, then there might be fraud in the first paper, but it might still be valid.
Very complicated. Yeah, thank you so much. I'm the timekeeper. That's not the good position, but we have another session after this. Thank you very, 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 very much, Elisabeth, for these very, very interesting topics. A lot of questions. Perhaps we will invite you next time for a next conference in order to follow this discussion, which is really actual and in each country. Thank you for being so numerous and have a good conference. Elisabeth, see you, and thank you so much.
Thank you for having me on. Bye-bye from California.
Bye-bye.
Bye-bye.